Now we're moving from gaming to healthcare. Let's welcome our next speakers, Cosmin Panaete, Business Process Director at Regina and Marian Simpetru, Managing Partner, eSolutions. Each with more than 20 years of experience, Cosmin was part of the Big Four, having expertise in areas such as audit, corporate governance, and risk management. Now overseeing the entire operations of private healthcare network Regina, while Marian occupied various software development positions from programmer to architect before founding eSolutions in 2001, quite some time ago. In the last year, he has been actively involved in conceiving big data platform architectures alongside his team. They will share how a hybrid big data platform will may be the way to achieve fast and centralized access to all of the data, giving you the power to improve both operational processes and also better determine patients' needs and more accurately predict the possible risks that they are exposed to. Cosmin, Marian, thank you for joining us. The stage is all yours.
Thank you very much for taking the time to attend the talk we're about to give you. It's, as mentioned before, about the big data platform, which is a hybrid big data platform that we developed with and for Regina. We're gonna give you some insights about the technical specification that were made during the development process, because this is still in development, and as any big data platform, it's a live organism, it evolves. And from the business perspective, Cosmin will share some insights with you, why it was this decision to build a hybrid big data platform, both on-premise and on the cloud, and which cloud was chosen and for what reason we've done this. So, Cosmin.
Hi, everyone. I'm Cosmin. I'm Business Processes Director for Regina. In this quality, I also take care of the IT strategy of our group. Who is Regina? We are an integrated healthcare provider covering from polyclinics, laboratory, logistics, hospitals, and so on, the entire country. We have around 5.5 million patients in our database, and we serve around 1 million per year. Now, big data. We started a couple of years ago in building our data lake and data warehouse platform. The problem with healthcare, I don't know if you know it, is that it's a very fragmented market, data-wise as well. There are a lot of standards. Everyone tries to make their own standard, not only big states such as US or multinational, multi-states such as EU, but also every state and even every provider. So there are a lot of data models implemented, and everyone is struggling to standardize them. Now, for Regina, our biggest asset in terms of IT, we think is our medical data, and what we try to do is to ensure the future of this data. Meaning, we are trying to port it in a format that is universally understandable, that is interconnectable with other suppliers, and we try to, let's say, match the future trends of the industry. There is a medical format that is kind of gaining advantage now. This is imposed by the Americans, is the FHIR standard. And hopefully the European Union is trying to get more or less in the same direction, and they will do an interchangeable data format. And we're trying to move our historical data, which lasts from, I think, 2010, the oldest one, to an international format. One of the reasons we've chosen Asia was the fact that they are providing a FHIR service, and we're trying to map our localized data to them. Why? Okay.
Yeah, so
I'm skipping ahead. Let's take it step by step.
Yeah, disclosing some information already. A little bit about the agenda, very simple topics. the need for big data in Regina Maria, a little bit of maybe more context that we are about to give, and some explanation about why we chosen the hybrid architecture, some advantages of using it, some advantages of using specific cloud, and some technical insights on the architecture, and maybe a little bit of what's to be expected to be developed next. So, yeah. Cosmin already mentioned about the high volumes of data which needs to be stored, which needs to be processed, which needs to be transformed, and they are all produced in various systems, some of them dating from many years ago. There are some of them, I might say, into the legacy type of application they were built. So together with changing the infrastructure, changing the processes, this challenge appeared into how to cope with all this variety of data that needs to be produced. So you can imagine you have all this data, but because we already managed to have a first implementation in last year already on premise, the need appeared to extract more from the same data and to add more data into it, because as I mentioned before, the big data platform, it's a living organism. So we need to evolve it to cope with the challenges that the organization has. So just to mention very briefly, of course, we need to store more, or to store everything that is happening, to go to real-time reporting. These are the challenges, right? And the goals, and to increase the reliability. And from the technical point of view, maybe you are familiar, or maybe if you are lucky, you are not familiar with these symptoms of crashing the execution after 6 hours of processing. Let's start it again, how to improve that. Let's do some more capacity, maybe we increase the hardware. So all this needed to be changed and to have a more very robust system. And another challenge is to expose the data. The data were produced in various formats by each producer, and this data needs to be exposed into a more uniform format so they could be consumed. How they are consumed, we might see later. But you can imagine consumed is made by other application, but also from the reporting layer. Yeah? And on top of that, another challenge which was very important is to have a uniform management over the entire processes, including deployment and runtime environment. For a non-IT company, this is a challenge per se when the infrastructure changed over the last few years with an increasing speed, but into these processes multiple vendors take part, and somebody needed to organize all the ecosystem in a way, and this was one of the challenge of the platforms itself. So maybe Cosmin.
So I will try to describe our context. We have in our industry there are a lot of different applications and different type of data. You have financial data, you have commercial data, you have medical data, and you have operational data that all combine to bring different KPIs and so on. And for this we have different applications. We have a hospital application, we have polyclinics application, we have a laboratory one, we have a CRM, we also have a billing for our subscriptions, corporate, an ERP, and so on. All these systems produce information, and the way we're looking at the data is to combine different information from different systems. And the first problem that we have that led us to the solution of data lake and data warehouse was the fact that there were two factors: the fact that the applications simply couldn't cope with the volume of transaction processed every day and the necessary reporting, and the fact that we had to spend a lot of time producing reports with aggregated information from various applications. And then we decided, okay, we're going to dump all the data in a data lake, take the information and restructure it in the data warehouse and so on. Now, we also have a mixed environment. We have 80% of our applications as of now are on-prem, and we also have applications that are in cloud. We have the Microsoft Dynamics CRM, which is a cloud-native solution, and we also have our stock inventory management solution that is also cloud-based. And moreover, we want to move our treasure trove of medical data to cloud in order to ensure security, the fact that we are sure that we maintain our history and interoperability with other players and our customers as well. For this, we had to make sure that we have some kind of mirror of our data lake and data warehouse in cloud as well, in order to be able to utilize the data in the application or with the application that are using them. So basically what we try to have is to match the production environment with a hybrid data warehouse solution, which is also 80% on-prem and 20% in cloud. What we're moving towards is in copying all our medical data and transforming it in FHIR formats in a cloud database, and from there bringing it in a data warehouse for analytics in cloud in order to utilize the machine learning application that we estimate that will appear. I have to say that for now they're not very mature, except for imaging interpretation algorithm, which we are already using, and I can confirm that for limited use cases are usable. I didn't see any machine learning universally applicable for medical as of now. Marian, if you want to add something here.
Yeah, we should mention that the entire platform also takes care of the daily operations of the processes. This was not intended initially or with priority towards analytics or doing some machine learning and artificial intelligence on top of it. This will be the cherry of the on the cake afterwards, but the primary goal was initially set into preparing the data and changing the data into the system and preparing for the reporting and some regular analytics, and makes the entire process very stable. And due to the fact that data started to be produced in cloud and on-premise, of course, we had to come with this hybrid architecture.
Basically, what we've seen was the fact that the entire workload of extracting data for reports was taken out of the our applications, and previous to that we had, let's say, nightly processes that run the entire night, and a night wasn't enough for us to extract all the data. Now it happens seamlessly, and if it interrupts or so on, it's able to take over from the moment it has left without any impact on the operational side. So basically, users don't see the impact of data extraction from the operational systems.
Yeah, and if we are about to talk about the advantages, they are absolutely obvious. Cost optimization. There was already in place a data center with all the servers where data were produced, so we just use that. And if we are talking about the cloud, of course, we have direct integration with data produced in the cloud, the CRM, for instance, and the healthcare interoperability resources, the FHIR. As mentioned before, it's a goal which we work towards in order to come with a healthcare information in the standardized format. And of course, the machine learning diagnose support through machine learning and artificial intelligence is the next step, already started to happen. Why Azure?
I'd like to explain the previous one, the previous slide a little bit from my point of view, or our business point of view. We didn't want to jump into the cloud movement head first. We wanted to dip our toes over there and basically use the data where it is produced and where it is needed. It doesn't make sense for us to move my entire data lake and data warehouse in cloud when all my applications that are producing are on-prem and all the users that are consuming are also on-prem. So basically I'm trying to keep the data where it is produced, more or less, and where it is used. And I'm transferring from cloud to local and from local to cloud the data that is needed by the users in each location. I cannot deny the fact that it's also a cost-conscious decision because cloud costs are high and are recurrent. And once you go there, it's very hard to step back. And I like to hedge my scenarios in order to be able, if I don't like it, to withdraw at any point. More or less, moreover, I don't have cloud native application except for the one that I've described, and I don't see future for them to go in cloud. My actual suppliers in their pipeline, they remain with local application. And frankly, there is no valid business case to move over there and accept the cost, the increased cost of having a managed service with Microsoft engineers. I prefer my engineers and my hardware, which are much cheaper. Now, on the flip side, why we've chosen Microsoft. There are two major reasons. The first one is local support. And the second one, that they are very business oriented. It's very hard to find Google or Amazon people speaking business here in Romania. You don't have anyone. We are not an IT-wise company. We are using the knowledge of our suppliers, and we lean very much on our suppliers and on the suppliers of the solution that we have. Moreover, we are a company that is accustomed with Microsoft solution. We have everything from Microsoft, from database to the solution in which our applications are built are Microsoft solution and so on. But the most important one was the local support. Microsoft provides, and I have access to technical resources from them provided by the local organization which is present in the market. When you are you are a company like me, which is not an IT-focused company, you have to use the best resources available on the market. Unfortunately, for the other cloud provider, Romania, I don't think it's a market. I mean, probably there are 2 Google employees in Romania. I don't know if there are any Amazon employees related to this market. There are a lot, but serving other markets.
Just want to point out that if we are talking about technical skills, yeah, we can. For instance, we can help with highly skilled, certified technical teams on cloud agnostic platforms. Our engineers have certifications in Microsoft Azure and Google Cloud Platform or Amazon Web Services. So Cosmin expressed here his
my point of view, Regina.
Point of view regarding the business side of the operations and consulting and all the rest. Yeah. So there are some other advantages regarding Azure in this use case. Of course, there are some software running and producing data in Azure, the CRM, right?
Not only CRM, but they were the first to provide me with a fire solution ready-made. So basically, I think they are ahead of the others in providing a comprehensive end-to-end solution for the fire format, including database structure, storage, and interconnection. So basically, we're relying on their knowledge to structure our data. And I think they're ahead. what I see, and again, I'm not a technical person, I only speak from the business point of view, is the fact that Microsoft solutions are one step ahead in getting closer to business. Maybe they're not, I don't know their technical level and so on, but they are making them easier to understand for people like me and how I can use them. It might be even from the fact that I have a lot of history with their solution as well, but I'm telling you only my experience.
Yeah. Now maybe the boring stuff for some of you, or a little bit interesting facts for the rest of you. As mentioned before, this is a platform which is still under construction, it's still expanding, and some of you might even saw the presentation we had last year when the platform was already operational only on premise, and since then some things added, changed and improved. Of course, we are talking about if we start with the source layer, we added other data sources to be ingested into the platform to be later on transformed, etc. So right now, just fun fact, we are dealing with 9 operational databases. They are support for data and store data for various applications, some of them existing since the beginning of the times of Regina Maria. Yeah? Some of them being Microsoft SQL Server, some of them being, for instance, Sybase. This is done through batch processing or change data capture. We are using NiFi to ingest the data into the platform. What have been added, it's another source from the cloud. It's from Microsoft Azure. Some data are needed to be taken back from what's produced there. The entire ingestion is done into a transient zone, and then some entities are produced via Kafka with events, or in HDFS, they are stored only in transit. They are processed using a Delta Lake format, and they go into a current zone where all the entities are processed and regulated with latest information. For that, multiple Spark jobs are used in parallel, of course. Some Spark streaming is used. Sometimes they are batch processes. So we construct this image within Delta Lake with current situation. This means whatever data we already ingested, we are able to say what's the current status about this entity. And via some Spark again, SQL-based like transformation with Spark, we are constructing some entities which are later used to be shipped into data warehouse. In this case, it's a Vertica data warehouse. Some of the reporting relies heavily on this Vertica warehouse, and some of the reports relies on the Delta Lake itself, where we are able to put more compute power in parallel in order to finish at whatever time frame is needed. Of course, the data are shipped also in Azure Synapse. And on top of that, as you would expect, we have monitoring alerts using Elastic, Logstash, Kibana. Grafana is on top of this. So yeah, again, as expected. More or less the same diagram, only with a little bit of insights on the cloud side. So as mentioned, data sources, Apache NiFi, everything goes into the data lake, processing using Spark, data lake again to store some information, to have history. And this was important as an upgrade into the platform. We started to use Delta Lake because it has specialized, it's like an upgrade of Parquet files with some history and versioning on the information. Yeah, and we ship information into data lake store generation 2. This is too technical, but it's, I think, the fancier stuff you can use there. It's similar to what we use in on-premise. For this, we use Databricks instances in cloud, and with Azure Synapse Analytics, these are done through some links over the Azure Data Lake store. And of course, data are exposed to the BI tools also in the cloud. There are several other side projects on top of the big data platform and pipelines to experiment and to make the first usages with machine learning and stuff, but we won't go into details with that. From our point of view, from the technical point of view, of course, the platform will expand. Some other data sources will be added, some more processing will be made, because the BI and analytics side will demand more data into the platform. But next steps, there will be, besides that, implement more machine learning thing to have some predictions, for instance, or customer segregation. This is a pure technical objective, like unified deployment infrastructure in order to have a simplified view over the on-premise infrastructure and in the cloud, and integrate more of the operation flows into the big data, because as mentioned, the big data is not just a silo of data, but it actively integrates and export and import data. Here we added some Kafka, and some other development using Kafka will be used probably. So yeah, on the business side, maybe some.
So on the business side, the key development for us will be to migrate our entire medical history on the FHIR standard, and from there to take it in Azure Synapse, in order to be for us to be able to build algorithm that analyze it in a let's say standardized format. Part of this would be even structuring our data, because we have a lot of text data. A lot of our medical records are simple text files or text fields in which the doctors have completed a lot of parameters that can be extracted through tools provided by our cloud platform. So basically we can transform data from unstructured to structured wherever possible. And basically this would be for us, let's say, our safety net. The fact that we will have a copy of our entire medical data in the cloud in a structured format.
Yeah, I skipped the infrastructure stuff. The entire big data, it's Kubernetes ready, or the entire clusters, including Spark, Kafka, whatever is there lives within a Kubernetes cluster, so it can be moved within different type of infrastructures. And yeah, I think that would be it, right?
How we are with time? Oh, okay.
We're fast.
Thank
Questions?
you. And questions? Do we have questions?
Okay, you didn't like the session.
All clear. Thank you very much. No?
There are questions.
Oh,
There are questions.
okay.
So.
We'll take 3 then.
So thank you for the presentation and the pretty interesting. How are you addressing the critical topic of data confidentiality of health data, personal related?
From what point of view you're asking? So this is a private instance. At this moment is basically our internal infrastructure. We're not exposing the data to anyone. It's like a redundant copy utilized only by us internally. So we are not exposing customer data to any external source, and we are not using customer sensitive data in an, let's say, non-anonymized form. If you can be more concrete on the question, maybe I can answer even more detailed on this one.
Thank
So
you.
basically, we're not extracting the data from our infrastructure. So our cloud instance is secured through VPN. It's like we're having the data in the same network, and we're not utilizing for extracting data at this moment. The moment we're going to utilize the data for, let's say, various reports, we are anonymizing the data. We're not at this moment producing, let's say, medical reports on the data. And we don't have any interest as of now in, let's say, selling the data or so on. Even interconnection with other players is at a very incipient stage as of this moment. If it's going to be ever possible, we're going to provide the power to the customer, so it would be customer initiated, and for his decision if he wants to share our data with other providers and so on. Was my
Thanks
answer
for the question.
satisfactory?
Any other questions?
Yeah, thank you.
And thanks a lot for your talk.
Thank you.